It is free alcohol.
Brain cells are sinking. Math together.
But if it's not, yeah, it's like, last year, actually, I was like, it's still, it's heavy. Like, the highest. Like, there's no. No, I mean, no, I know.
You have to turn to page 9 in your test review packet. So there are so this new packet, I do want us to, I do want to go over some problems, but I'll wait till Monday. We have some time before our next quiz, which is next Friday. Again, next Friday's quiz will just be one particle motion and then one Taylor series. So we'll have plenty of time to I'll go over any questions that you guys have from that packet. But let's focus our attention to worksheet 3. It's a pretty long worksheet, and I organized this worksheet by topics. So I like to, let's do the odds so that we can kind of make sure we kind of see one of each type. And then help session tomorrow morning, 7:15, I will go over the evens. But ideally, you guys have time tonight to work through all of worksheet 3. So if you have specific questions, you can get those answered. But I can also go over it tomorrow morning. Okay, so go ahead and start with number 1. I would like to just kind of pace us through each of these problems. So I want you to try it before I go over it with you. Okay, so page 9.
Page 9.
Page 9 off of the test review packet. Yeah, test review packet. So the test is not going to be over the FRQ. It'll be over 10.5 to 10.10.
Sorry, repeat that.
It's the test tomorrow is not going to be over particle motion and Taylor series. Well, it is over Taylor series, but it's more like this format.
So if we just look at our 1, 2, 3, which we did.
Yeah, you should be good. You know how to do that. You.
Yeah.
Yeah, but what a slacker.
That's like short. Like which of these? Where the options like T,
Yes. Yes. In English for someone, but they had to be like your first confirmation after showing up. Yes, it's zero.
I just don't want to use this now. I know right now.
Oh, wow. I'm actually so desperate.
One of the things I can actually study this job. Oh, I'm having my when I go home. Oh, it's not.
Oh, it's the test calculators.
Calculator, yes.
Oh, I thought it was.
Right. Well, on the AP exam, number 6 FRQs we've been working on, the Taylor series, those are non-calculated. So just want to give you a heads up there. But for all my assessments, it'll be calculated.
After I eat lunch, I feel like narrow. So I'm thinking like there's gotta be something towards it, right? It's my electrolytes that are off. Like when I eat, there's gotta be something that goes off my electrolytes. Well, I'm doing.
And if you want to.
Yeah, I think that's emergencies.
No questions. I have 11 through like 18.
If we want to send a text to my phone.
Yeah.
Yeah, it's on the 10.1, no, we're like 10.5.
Like one, thing, I'm just gonna get the entire beer.
Do you want to become a perfect home harmony?
It doesn't work, yeah.
You have to like out.
I think it does, but it's deep.
Autism and Down syndrome. Conflicts.
It's like working balls, like.
Yeah.
How
can I help you?
The one shit, the like.
Does he also mean?
I'm not.
But it's good.
I think maybe like from this, and look what I do, so.
I'll probably
like,
be there like twice a
for the
week.
gym,
It's awesome.
maybe it has sugar in it, so that'll be good for the gym.
There's also meta.
But yeah, I think it's like, I think they feel like what I do, right? Regular water.
Right around getting the folder right after. It's like.
Raj.
Every year's like.
Like what I do for a little bit.
As long
As long as it's not someone that you know.
Oh, I consider doing.
Yeah, and all
What? What was the coefficient?
I'm just doing that. Yeah, that's not smart. Yeah, I know.
like.
Because what's wrong with that? One is like. This. Like. Yeah.
Oh, yeah.
That's all.
No, but it's good to go to listen.
I don't know. Otherwise it doesn't work out because.
Actually, not really.
Well, being able to sing songs. Also just.
Look at how needy you are. Mr. Young's having a need for us to put a whole different
I
packet.
mean, as long as you're not going above your daily, the eye.
It's like, psychology is not.
And that's like the.
It's more human behavior.
Yeah.
Instead of the fun class.
The number bigger than.
Getting them, you're really missing out on. You just split up this, alright.
So I want to see how low.
You just missed out on the.
So we flipped this.
Sound issue. What happens?
Josh and I are not one for our calc physics. That's
Grow up.
It's gonna be just helpful. Yeah, I'll check if you're very the class before and after. Yeah.
Joshua.
I know what you want.
Oh.
Didn't care, but like.
Computational token rotation. You got this. It's language. It's language. Holy cow. It's the easiest thing. Josh. Yeah. What easiest you? I almost failed. What? Oh, wait, no. Rotational motion. It was, I had to make like come back of the century. It's really. I didn't make it come back up. I was at like an 88.
Like this study was for one. I my birthday.
I got up at 89, but not during.
Gonna do all.
So, oh, no, I was gonna, 89.
That's why I
Bring up some. Thank
Thank you so much.
And then.
Thank you so much.
That's
Well, I said it was big follows.
Is anyone else missing the test review packet? Okay, so number one. We're just doing, let's do the odds, odd number problems here. So we know that if we're looking at a alternating series that converges, we know that our partial sum is going to be at worst off by no more than the first unused term. So if I want to figure out how accurate my 50th partial sum is, I can simply look at my 51st term. So if my 51st term, sorry, my 50th partial sum is going to be off by no more than 1 over 103 off of the exact value. Even though we don't know what the exact value is, we do know that it can't be, we're pretty accurate. We're only off by at most 1 over 103.
This formula has like conditions. Do you have to write those out when you're doing
Uh,
the problem?
No, not for this, unless the problem specifies, you know, justify with your reasoning, but on the tests, you don't have to.
Okay.
But in general, you'll have to list it out if they ask for it, if they ask for conditions, like on the AP exam. Okay, number 3.
Like within a number, does that mean you just need less than?
Less than, yeah. Yeah, just less than, yeah. So we want to be inside of 0.02. So we know that this alternating series converges. What's the least number of terms that guarantees that we're within 0.02? Now, we don't want to do a trial and error because this will take too long. So the idea is we just go ahead and look for the first unused term. So the first unused term is we want the n plus first term to live inside of 0.02, to be less than 0.02. If the n plus first term will give us a value less than 0.02, we know that the partial sum S of n is going to be have an accuracy that is within this error. So algebraically, we just, again, we can ignore the alternator because when we talk about error, we always talk about a positive number. So we can just drop the alternator, replace n with n plus 1, and I'm just solving for n here algebraically, cross multiplying. And I know that n has to be greater than 2499. So the smallest n value that will give me the error bound I'm looking for is 2500.
What happens if you're not paying attention, you just don't drop the alternator?
Yeah, so we memorized this formula, right? So the formula that you memorize has the absolute value. So hopefully the absolute value will just remind yourself that, oh, I'm just talking about positive numbers here. Because the absolute value will, if you have the negative value in here, the negative will drop out because you know that the absolute value will take away the negative. Yeah. All right, try number 5. Same idea with number 5. Replace n with n plus 1, set it to be less than 1 over 1000. Any questions with 5? Okay, number 7. That the function with third derivative f triple prime of x equals 12x to the negative 3. What is the coefficient of x minus 1 to the fourth in the fourth degree Taylor polynomial? So we start off with our definition, and we just are going to try to fill in as much as we can. We know that a Taylor polynomial is going to follow the formula nth derivative at c over n factorial times x minus c to the nth. So if I want to find the coefficient, I know I'm going to have to find the fourth derivative, evaluate at 1 over 4 factorial. That's my coefficient, and then the rest of it will be x minus 1 to the fourth. So if I can just figure out what this number is, then I know that's my coefficient. Okay, so they already give you the third derivative, so we just go through power rule, find the fourth derivative, plug in 1, get that fourth derivative, but you still have to divide by 4 factorial. Okay, if you're good with 7, go to 9. Okay, if I go through power rule a couple times, I should be able to get to my third derivative and then plug in 0. That next will drop out, so it's just 6 over 128. What did you get? You get what?
I got it.
120 divided by 6.
It's it's n factorial, right? So it's x divided by 6 times 128.
Oh, so I think this represents the function. So the third derivative at 0 is just the derivative of that function, as opposed to the numerator. So it's just like, if I'm giving you a function and I ask you for the third derivative at 0, you would just, it's just like a power rule problem. It's just like,
Like it would be x cubed by 128, right? So I take 3 factorial on the
I don't think we have to worry about the factorial because it's already built into the function. It's already embedded into this function. We're not having to build it from scratch with a rule of sequence.
Okay, how I was, okay, I get what you're saying. What I was thinking is, so is that expansion the third term of the Taylor polynomial, or is that just a? This third degree, so.
It's the third degree. So this is the approximation for f of x. For
Ideally, shouldn't we just be able to go to x cubed by 128 and just say that's the third? And then after the third degree polynomial, and then take 3 factorial out of the denominator, so 128 divided by 6.
That's what I did. Instead of going to 0.
you got the same answer. Okay. Let me try to work it out that way. And in the meantime, if you guys are okay with that, go to 11. But let's come back to number 9. Let me see.
I'm just going to share, but it's not charged yet. I can charge this.
Yeah.
In the back. Back there.
Yes.
Thank you. Thank you.
Okay, so if we want to match it up with our, Taylor polynomial, we know that the nth derivative evaluates 0 over n factorial x to the n, where the third degree it would be the third derivative evaluated 0 over 3 factorial x cubed. So we can set this equal to 1 over 128 and then cross multiply and get that third derivative value at 0. If you want to do it that way. Right, that makes sense. Okay, 11. Okay, here's the formula for Lagrange error bound. Um, the fourth degree Taylor polynomial, so that tells us that our n is 4. A Maclaurin polynomial, that tells us the center is 0. For cosine of x, approximate cosine power of 3, you know that's the x value. So right from reading the problem, we know what our n value is, we know what our x value is, we know what our c value is. The only work that we have to really figure out is what can we replace for that maximum of the n plus first derivative. Well, you're talking about cosine here, and you can go and find the fourth derivative of cosine, but all your derivative will just kind of circle around the same types of function, right? It could be like negative sine, sine, cosine, and positive sine. Now, it doesn't matter which one these are. These are all graphs that has a max of 1. So they all have a max of 1. So we know that if we're dealing with sine and cosine, we can just replace this with 1 because that's the maximum that the sine and cosine can be. It doesn't matter if it's negative sine or positive cosine or negative cosine. So that's nice. If we're dealing with sine and cosine, you know that numerator portion is just 1. And then everything else we have numbers for. And then whatever numeric value we get, that's going to be our maximum error bound. Yeah.
Has less, like always had a less than or equal to symbol for like the answers for these.
Yes. Yeah. Okay, try 13. Okay, so 13, we know that we're centered around x equals 2, that's our c value. F of 2.5, that's our x value. N is, they're giving us a third degree polynomial, so our n is 3. So if we increase all of our n's with n plus 1, then we want to find the maximum of that fourth derivative. And the nice thing is that they're telling us the maximum of the fourth derivative is going to be 12, so we not do any work, just have to replace this numerator with 12. Replace x with 2, replace c with 2 point, sorry, x with 2.5, c with 2. And remember, your error is always a positive number, so this case, 1/30. Okay, let's see if we can do 2 more here. 15 and 17. Seventeen, go through ratio test to. We're given 15. So there's three scenarios. If all your ends cancel out, then you know you're gonna get a typical interval of convergence with with a lower and upper value, and you have to end up testing your endpoints. The other scenario is if there's an n left in the denominator. If there is, then it's always equal to zero. If it's always equal to zero, if it's equal to zero, that means it's always less than one, which means that your interval of convergence is all real numbers, and then your radius is infinity. But if there's an n left over in the numerator, that means your limit will go to infinity, which is always greater than one, which means that the series will not converge except at the center. That's the case with 17. Radius will be zero. And your interval convergence is just a single point, x equals the center. Yeah. We ignore the three. Is that what you're talking about?
Like when we're finding what the seven is, like from the original like function, do we just like ignore everything except for like the end parts in the end?
Well, we know the center is at 4,
Oh, okay.
right? 4 is the only place that will cause this to be zero. Any other value will force it up to infinity. That's 0 is the only time that we can get that n to go away. So is that what you're asking? Okay, we didn't get a chance to get through all the odds even or odds for our worksheet, but it'd be great if you guys can have time to work through the rest of worksheet 3 tonight. And then tomorrow morning, I can answer any questions from worksheet 3 as well as work through some of the even problems. So help session tomorrow morning, 7:15. I'll send out a reminder, and then I'll also send out a Teams link if you want to join virtually for the help session. Also, make sure that you study through your previous quiz, right? Make sure you memorize that you know all your Maclaurin expansion for sine, cosine, all those important functions. Come with your phones. Yes, you get to use your calculator.
Can you explain your example to us?
Like, can you follow the NBA? The Celtics just got bought for 6.1 billion. What does that mean?
Let me just walk you through the room.
Oh my god. They're back. They're back. Oh, we believe in dinosaurs. So I can't talk about this talk. No, we can't. I want to know if they're first. I don't know. You can talk, you should understand.
Thank you.
Denominator converges for fund values.
If n is in the denominator, it will converge to all real numbers. So that's it goes like, over, and this is always less than 1. This limit. So your radius, your interval convergence will be all real numbers. Yeah. You guys can come up here. I'll just go walk through the answer.
I understand like scenario. It's like scenario 2. Yeah.
So if it diverges at 8, that means the center's still at 4, but then the maximum radius that this can exist is at 8. That means it could.
Oh, but the interval convergence can't include 8.
Is exactly right. This is the furthest that we can go is radius of 4 and it diverges at 8, but it can still have that potential of a radius of 4.
We actually need scenario. So I'm saying if we build scenario 2, do we even need scenario 1? We don't share scenario 1. I mean, I'm just.
What's the following?
Did I finish? Not all the stars, but I have all the diamonds. Yeah.
Yeah, we may not need it. I just want to just build out all my
Thank you.
possibilities in front of me and then look at my.
I haven't spent any points on check. You know,
Because it might not, it could diverge between
It
anything above.
could diverge at 1 because endpoints are not given. Only what's below that.
You know the question.
So, so for this scenario, my interval could be between 1 and 7.
oh, for
And for this scenario, it could be between 0 and 8. The endpoints are still in question. So those are possibilities. It converges here, or it could converge here.
So do you have to do both scenarios and build up both?
And you may not, but I like to have those scenarios in front of me just in case.
Like one of them fails?
Right.
We don't have to do it one for the middle.
Yeah, so let's say series converges at 2. This is guaranteed in both scenarios, so I can check that off.
But then if one fails.
Right, if one fails, then I can remove it. Right, so if I have everything in front of me, then I have just everything I need to make my decision. Series diverge at 0, that is possible here. And it's possible here. I mean, it's definite here as well, and it's possible here. So this is not a guarantee because we could imagine a scenario where the radius is 4 and it still converges here.
Also, on the first trigonometry, it's a -5 as the plus and equal and -3 instead of like -5 and less.
Oh, yeah, let me see. 16.
So they're all things.
Oh, less than. Is that what you said? Yes, I'm sorry. I've got that. Less than. Thank you.
Thank you.